So notice how we have like a grid of circles, and then I have this point, and basically this is what you call an attractor point. So wherever I move this point, that's going to influence what's happening below it, or it's basically the distance to this point that will affect how you're doing the commands below it. So you could do the same command to everything, or you can do different commands depending on where you go. So this is a different concept, but if you think about it, once you've created panels, instead of doing them in a grid like I'm doing here, you could do the same effect onto a whole set of panels that are all oriented differently. So I'm just showing you some different ways you could use Grasshopper to do this one from scratch. Like, once you've created one of these like attractor definitions, you can really easily like change it and do like whatever you would want to do. So instead of those, I can make so see, now this is done using polygons. So here the basic command that we're doing is really the scale tool, and what makes it unique is how you control the factor of what you're scaling. So when you look at it, that's kind of like the main thing to realize. This is just what is it that we are creating, and then this is all the factor of how we scale. This just creates like, so let me start off by disconnecting this. So let me draw full names. So that you can see this a little better. So scale is really what we're doing. I'm going to start and do this definition totally by scratch, but I want you to see kind of like where we're going with it so that it makes sense. So let's grab these guys. And we'll just start off from here. And then let me just turn off this one. So now this is the only thing that we have. So I have a random rhino point. That's the other way I could get there, just delete it, so that will fail. Okay, so I started off just creating like a rectangular grid. So this is just literally a grid. There's nothing it's created in there. It's just a grid, and then you have X and Y size, and then how many in the X and Y direction. So if I only wanted 5, I could do that. So say it's a 5 by 5. So this is literally just creating a giant grid, and then it will stay live, so I can expand it or contract it. This is the size of the individual like modules. You could also create this by taking, instead of creating a grid to populate all these circles, you could take the center point of every panel and create a, like the shape of the panel on there, or you could say I have a series of points already, I'm going to collect them and use this. Or maybe it's my floor slabs. As my floor slabs go up, I want to scale them in relation to a point or something like that. For this exercise, we're just going to use a random grid. The next thing is we can start off with just like a polygon. So let's say polygon. So what this needs is a radius. So the first one it made is down here. See that? And then it's going to need to know how many segments, if you want to fill out the radius, how big the radius is, and then what plane it's on. So as soon as you connect that, if you come back and look, so that has made it so that you are using the same plane. Is it that one or this one? There you go. So it's going to take every point on there and create one of these on basically on the corners of each one. So we really now don't need to see the grid. The grid is still there. I'm just turning off the preview to make it a little bit easier to see. You can tell now that we have a certain radius and then a certain number of segments. So I could write like a number and plug that into segments. And then as I move that down, I get more or less segments. So it's really just the one guy is changing, but since we're creating it amongst every point, it's creating it all over the place. So if I were to disconnect it from there, you'll see that this still happens, but it's occurring only in the origin point, because that's the first one. As soon as you tell it, don't create it only in the origin, create it at every one of these points, now all of a sudden you got like tons of them. And if I were to now change how many grid points or how many of my grid, it's going to change like that now. So that's the first thing to understand is happening. The next thing is really we're just going to scale it. And we're going to tell it use a scale factor, and then we'll see what happens, and then we'll see how we can tell it to control the amount of the scale differently, which is really, that's where all the like technique will come in. There's like 1,000 ways you can do it. Just like math, there's like a ton of ways you can create the same type of equation. That's how you would calculate this next step. So we have the basic shape. We can tell it how many sides we want. The more sides you get, the more it looks like a circle. So let's start like this. And then now we can change the size. So I can do, what's the default radius? 3. So let's do like 5. Oops, yeah, double click. And now if I make them bigger, they get like that. I can shrink them. So it's basically, we can do it however big we want. If you wanted it to match exactly like the size of one of these, you could do that. So let's leave that like that for now. And then if you apply a fillet radius, it'll just fillet all the corners, make them round. With this we get polygons and we get lengths. For what we're more interested in, we want polygons, right? So let's type in, what's the command we're going to do? Scale. So it says scale an object uniformly in all directions. So if you look up here, it's the same thing we have, except it's not plugged directly in, it's plugged into like this sort of thing. So we'll get to why that happens. If we just plug in straight in there, see what it did? All of a sudden it's made like a bunch of these like random things. So that's not what we want. We want it to be scaled along the center point of each of these. So if you look up here, I'm grabbing the center from the points. So we use those to create that. We can also use that to orient where you're scaling everything from. So if I grab this, let me move this one down, and you just put that straight in, now you can see it's scaling them down into there. So the factor by default is 0.5. So if you think about it, if you scale anything by 1, it's going to be the same size. So if you want to shrink it, you would be bringing it down. Small.
Bring the polygon to the center instead, would that make it shrink toward the center of the grid?
Let's see. It probably will. It might fail. Let's see. Because now it's saying it's probably collecting the wrong type.
The geometry one, the geometry scale, one right above that.
This one?
Yeah, if you click that.
Oh, if you undo it?
Yeah, because that'd be scaling it twice, right?
Well, this is looking for a different thing. It's looking for a point, the center of scaling, and we're giving it a polygon.
Gotcha.
So you need to find something that's giving it a point. say this is giving points out, 100 points. So that guy would want to go there, and this guy has to at least get points somehow. You could do it a ton of ways. What you could do is run an area component and then put that in there, and then from here you can get the center, and then that will give you the same thing. But since that point is also the same as that point, you already have it, so you can get rid of this loop, and you basically bypass it by doing this. But if you don't have this kind of condition, that's in a way you would do it. You would somehow find the center point of each of those. Now I'm going to put a factor there. So I know 1 is kind of my max. I'm not trying to grow them. I'm trying to shrink them. So I'll probably put like maybe 1.55 or something like that. And then we can bring this down and look and say, okay, so all of them are doing it exactly the same. So how can we now start telling it it's not going to be a fixed number that we want? We want to control it to be a distance from a certain point, right? So this control point that we're going to do. So let's just create a random point. I'm just going to do a rhino point because it's quicker to move them. If you could do a construct point. Construct point. But then you got to use 3 sliders to move it. It's like, so you could do that if you wanted.
Just gonna reference the point.
Yep. So then now I would type in point, or you could do geometry, or you could do this a ton of ways. And then I'm going to tell it set 1 point, that one, and see now it lights up. And it'll turn green, and I can move it around, and it stays with it. So now let's say I want to measure the scale by the distance from this point to what point do you think?
Center.
So the center of these guys, which we were getting from here, right? So now is that going to return a number? Yeah, see, it's getting a bunch of stuff. So let's try putting that in here as the factor, and let's see what happens. So why is it doing that? Because when you measure, so when you measure the distance to any point, it's always going to return a value, right? Because I have a distance to you that's different than the distance to them, to the door, to the wall. So it's always going to find a distance. It's impossible for it not to return a distance unless they're on top of each other. So what I would want to do now is to say, okay, here is, let's see what kind of distances we're getting. So I have a panel. And that should tell you, see, like we're scaling by a factor of 49. And that's just the first row. As you go down, like I'm sure there's some that are get way bigger. Oh, I guess those are the biggest ones. Some of them you can see it's closer, so they're scaling smaller. So what we need to do now is start somehow controlling the maximum amount that we're scaling, and then also reducing that factor so that it's not over the number 1. So up here, what we can do is set up this command, which is called minimum. So after you measure the distance, you can ask Rhino to check the distance and pull the minimum of either A or B, and then here we could put a number, let's say like 50, and you could put that in and then factor that. So we could do this and see now we're bringing it down, but in reality it's always going to return whatever you put here unless your distance is somehow less than 2. So if we look up really close, you might have gotten lucky if you put it like within one of these. See there, it's starting to scale that guy down, but everyone else is larger than that. So it's ignoring the fact that the distance is more than 3. And so even though here, if we put a panel coming from there, you have all that information. If you put another panel here, look at how many times it returns the number 3. Basically, every single time you're more than 3 away, it'll return the number 3, because this tells Grasshopper to choose the minimum. So it'll take number A is 46, number B is 3, you're going to get 3. And so 3 is what's flowing into there. So it's scaling everything by a factor of 3. So we don't want it to do that endlessly. If I make this bigger, now all of a sudden you get 30s, or here it was something that was less than 30. But what if we could find a way to tell it, you should return the number 1 if it's more than a certain distance away? So if you look up here, what I've done with this is pretty simple. You just add a division, and so what this is going to do is divide our number by this. So it's like a smaller factor, and it does two things. So we can do this without minimum. So let's just do division. So let's put that factor into there. So we have these crazy numbers, but we're dividing them by a factor, right? So now it's kind of working, but eventually you get out past the edge if you bring this down. See? Quickly, like, it blows up. And if you had a ton of panels, like, we're scaling all the panels regardless. You'll never have a panel that's the normal size. It's always going to scale at some factor. So what we need to do is write this in a way that it can somehow start to return the number 1. And so the easiest way to do that is to first say, take the minimum, and just by doing that, run through the logic. So you'll get minimum of the distance versus this. And if we put a circle here, so circle, so center is the point. This is just so I can visually show you and the radius. So as I shrink this, notice how that is where it's affecting the impact. And so why does it not affect it outside? Let's do that. Let's run through it. You check the distance, it's going to return a number, right? All these different values. And then we're telling Grasshopper, compare that to this number. If it's larger than that number, ignore it and take this number. If this number is smaller, carry that number, and now divide it by this, and then use scale. So if we get any number that's larger than this number, it will return 29 right now, and then it goes through and then divides 29 by 29, which equals what? 1. And so anything outside of that gets scaled by a factor of 1, so it's basically the same as it was before. So it's going to create a new geometry. See how they light up green? Because it is, but it's scaling it by 1. So this little circle, that's just there to show you kind of as we scale this number visually where it is, but that is not really part of the definition. The definition here is there, and then you can do that to go more or less. And if you want, next week, once we start looking more into this, I'll show you, you can use this same sort of definition. You slightly tweak it, and you can make it apply to curves. Instead of distance, you can use curve closest point. You can set a whole group of these, so there's like multiple points everywhere that you can like attract to. You can have it also apply like rotation, so you can rotate more or less based off the distance to one of these. So let's say you wanted to have like a series of panels and then slowly open up to allow sunlight in, and then slowly close in other areas. you could do that. So you could pick kind of like the points where you wanted your building to start opening up for views or visibility, something like that. And as the panels get closer, they start to rotate open, and then you can have it rotate them back where they're fixed. Or you can do the same thing that we were doing before. You can scale them down. And so look at this in two ways. One could be the original panel doesn't exist anymore. So this one, and then you have that. The other way to do this is think of the real panel is still there. These are like the window or like the opening. And so like you can use this to control. Have you seen buildings that are like modeled like this where the windows are just like small little openings and eventually they get bigger and then the whole panel becomes a window and then it starts to shrink again? So you could look at this as a way of controlling that, so that instead of having just either solid window and then solid closed, you can transition through it. And right now we're applying it to a very fixed sort of like grid, but the same thing will work. The only difference when you apply this kind of logic to like a paneled surface or like a curve is when you do this step where you define the plane, it's not going to be the flat XYZ plane. It will be whatever the normal direction is of that panel, because the panel might be rotated like that, or it might be like this, or it might be like that. So as long as you can align each polygon to the right plane normal, then it works just fine. So that's where it starts getting like one step more complicated, but then you get more value out of it. Does this make sense a little bit? Some? So just play around with this. You don't have to do all of this on yours. I'm just asking you to use Grasshopper for one step. It could be the structure, it could be the panels, it could be to make the initial form. We did last week the tower, and then this week I showed you a couple other kind of things you can do with it, like paneling and then attractors. And next week we'll look at some plugins like Lunchbox, which notice has paneling and structure, and so those will help you out a lot, because those basically, it creates stuff like this where you get your surface, how many times you want to divide it, and then it gives you the structure and then the nodes. And so it's just kind of simplifying these definitions that we've been working on so that it helps you work faster.
Do you have this on Canvas by chance? Like, not necessarily this exact, but do you have any definitions up there?
I can put some. I can get you guys some. And I'm recording this right now, so if you wanted to follow along and just rebuild it,
okay,
I'll post this one up too. I also have the tower completely, like as an entire video. So yeah, so if you guys don't have any questions, that's what I was planning on covering for today. It's kind of get you started on this and showing you where we're going.